of sums and differences. So let's be clear about something. Take out your calculator. Set it in degrees. Sign up to give blood. All right, I want you to type sine 27.
27 sign?
Yep, 27, sine 27. And I want you to add to it the sine of 23. So see what that is, sine 27 and sine 23. See what that number is. Okay, you see that number? Now, I don't care what it is. Now, do sine 50. Is it the same number? No. Because, kids, sine is not distributive. The sine of 27 plus 23 is not the sine of 27 plus the sine of 23. It does not work that way. None of the functions are distributive. So if we want to find the sine of a sum, we have to use a formula for that. The formula's in your notes and it's also on your sheet. What does the formula say?
Sine, whatever that A.
It's alpha and beta, probably is what I put in the notes, yeah. Alpha and beta, but it's first and second, right? So the formula says it's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. That's how we would do it. Now, we're not going to do that problem because I need a calculator for 27 and 23, and I might as well just type in sine 50 if I'm going to do that. All right, but that's how the formula works, okay? So we are going to find the cosine of 15 without the calculator. So put the calculator away. And now we're going to find the cosine of 15. Now I want you to think about 15 for a second. Can 15 be broken apart into either a sum or a difference, because that's what you got here, adds and subtracts. Can you break it apart into a sum or a difference of angles that you can do without a calculator? Like 23 and 27, I need a calculator for those. But think about the angles you can do without a calculator.
60 and 45.
So one option would be 60 minus 45. That's a great option, right? Does that give me 15? Did anybody think of a different option? 45 minus 30? The work's going to look different, the answer will be the same. So your job is come up with an option. So that's a good one. Now what does our cosine formula say? Cosine of a difference says take the cosine of the first times cosine of the second plus sine of the first, sine of the second. Now, in the sine formulas, I want you to look at the sine formulas real quick. When it's sine alpha plus beta, the formula has a plus in it. When it's sine alpha minus beta, the formula has a minus in it. I always remember that in the sine formulas, the signs, S-I-G-N's, stay the same. SSS. In the sine formulas, signs stay the same. Look in the cosine formulas. When it's cosine of a plus, the formula is a minus, and when it's cosine of a minus, the formula is a plus. Okay? Now, that's step one. Is everybody with me? So now we have to figure out four numbers. So, we either have those memorized, or we draw a picture of a 60-degree triangle and a 45, 90 triangle. And we just start plugging in the numbers. So what's the cosine of 60? 1 over 2. What's the cosine of 45? 1 over root 2, which I'll probably say root 2 over 2. Are you alright with that?
Jason.
What's sine 60? Square root of 3 over 2. And the sine of 45? 1 over root 2 or root 2 over 2 again. Now, these two are being multiplied. So what happens when I multiply these? Root 2 over 4 plus, now these two are being multiplied, root 6 over 4. And wonderfully, they have a common denominator, so I'll just go ahead and say root 2 plus root 6 over 4. Root 2 and root 6 do not add. They don't have the same radicand. They don't have the same number underneath. So therefore, the answer, the exact cosine of 15 is root 2 plus root 6 over 4. That's not too hard, is it? Let's try the next one. Sine 75. I'm gonna leave my triangles here because I'm probably gonna need them again. What are you doing with sine, what was it, 75? What are you doing with sine 75? 45 plus 30. Sounds like a good plan. So sine 45 plus 30. All right, what's our formula say? Sine 45 cosine 30 plus cosine 45 sine 30. Are you making sense of your alphas and betas in there, guys? All right, so once again, we got 4 numbers we got to fill in. I did not draw my 30 triangle, but I will. So now I have all my triangles over here. So sine 45 is root 2 over 2. And oh, by the way, so is cosine, right? Fill that one in. Cosine 30 is root 3 over 2. Sine 30 is 1/2. Multiply the first 2, multiply the second 2, and add, oh my golly! Is that the same answer we had a minute ago? Okay, well, 2 things. First of all, I am not going to be shocked when I keep getting the same kinds of answers over and over again, because after all, these are the triangles I'm using, right? So if I only have these numbers to use, then of course they're going to be similar. Some positive, some negative, whatever, but similar. This one was sine 75, and of course it matches cosine 15, because what's the relationship between 75 and 15? They're complementary. And what do we know about the sines and cosines of complementary angles? They are equal. Sine 50, cosine 40, equal. So of course it makes sense here that these would match. So if we'd had our thinking caps on and we would have done all that, we would have known what the answer is. But good practice. Tangent 285. Tangent 285. Now, are we conscious of the fact that while I have drawn let's just look at the 30, I've drawn this 30-degree triangle, that there's actually a 30 in every quadrant. And the only difference will be the positives and the negatives, right? So there are really 4 triangles here, and there are 4 here and 4 here, because I could draw them in every quadrant. So, if I need to end up with, what was it, tangent 285. are not locked into just 30, 60, and 45. It can be any 30. So it could be 30, 150, 210, 330, right? And the same with these guys. So with that in mind, we're adding or subtracting, either one doesn't matter, adding or subtracting to get 285. Can you think of a combination? George?
330 minus 45.
What?
330 minus 45.
330 minus 45. First of all, does that make 285?
Yes.
Okay, so he's good to go. Are there other options? Yes, but I like the way George is thinking. When he saw this 5 on that number, he said, I'm gonna use a 45. So he said 330 minus 45. I personally would have said 240 plus 45, but there are lots of them. There's so many, 150, 135, I mean, there's zillions of possibilities. We're gonna go with George's. What does the formula say then for tangent? Oh, shoot, I don't think I put it in the notes. Is it on your sheet?
Yeah, it is.
I did put it in the notes?
Yeah, it's on the
There's,
Oh yeah, I got it in there. I got it in there. Okay, so it's on the sheet too, either one. So what's the formula for tangent alpha minus beta? Tangent alpha, tangent first, minus tangent second, over 1 plus tangent first, tangent second. Is that okay with everybody? Now, I went ahead and read through my 30-degree triangle in quadrant 4. 330 looks like this. Would everyone agree with that? They're good with that? So what's the tangent of 330? Negative 1 over root 3, or I would say negative root 3 over 3. At some point you have to rationalize, so I just do it as I go. What about the tangent of 45? What's the tangent of 45? 1. And then we have the exact same two numbers in the bottom, tan 330 and tan 45 at the bottom, at their times in the bottom. Okay, so I've got negative root 3 over 3 minus 1 over 1 minus root 3 over 3. Nothing in that problem cancels. Do not even think about it. It's never going to cancel. The signs don't line up. You cannot cancel. Don't even think about it.
you have to rationalize that.
You have to get rid of the complex fraction. So we're going to do whatever you want. I'm going to multiply everything by 3. And that's going to leave me, let's see how much video room I have here. That's going to leave me with negative root 3 minus 3 over 3 minus root 3. Is that okay with everybody? Still, nothing cancels. Negatives in wrong spots, too many negatives, can't cancel anything. You learned in Algebra 2 that you're really not supposed to have something like 3 minus the square root of 3 in the bottom. So how do we take care of that? 3 plus the square root of 3. We call that the conjugate. Foiling everything now, there's a lot of arithmetic. Personally, I don't like the tangent formula because it has arithmetic, but we have to do it, so. how's my foiling look? So negative 12 minus 6 root 3 over 6. Now you can cancel. Now you can cancel out a 6. And you're left with negative 2 minus 3. Alright, take those calculators back out. Type in tangent 285. And then type in this number, just to prove to yourself that this works. This is all legit. Did it work? Of course it did. Of course it did. All right. So we're done doing those kind of problems. What is the strategy? If somebody says to you, find the cosine of 255, what are you going to do? You figure out something that either adds or subtracts. One of these guys that adds or subtracts to whatever your angle is, right? And then you use the appropriate formula. Easy. All right. Next, it says verify. Well, you know what that means? That means pick a side and change it into the other side. That's what you've been enjoying the past few days. Now, this is actually a co-function identity, so you're actually proving one of our main identities. This is a cosine of a subtraction. What does the formula say for the cosine of a subtraction? Cosine first, cosine second, plus sine first, sine second. Remember, the cosine formulas, they're different. Yeah, what's pi over 2? Where's pi over 2? 90. So 90 is right here on my unit circle. What's the cosine of 90? 0. Because cosine is x. So cosine is 0. What's the sine of 90? 1. So 0 times anything is 0, it's gone, and 1 times sine. Did this work out for us, kids? Yeah, sure did. It's an identity, I hope it worked. All right, you try this one. You try this next one. Sine x plus pi. Sine x plus pi. Lucy, how did you expand sine x plus pi using your formula?
You do the sine of x times the cosine of pi. What's the cosine of pi times sine x?
Actually,
Wait, cosine of-
cosine x sine pi.
Yeah.
I'm not sure why that was so funny, but I'm glad you enjoyed it. Where is pi on the circle? Right here, right? Negative 1, 0. So cosine pi is negative 1. And sine pi is 0. So that's gone, and we're left with negative sine x, which is what we wanted. Easy? Hang on to your hats. All right, here we go. So tangent of a difference. So what's that say? Tangent theta. You can call that x if it's easier for you. Tangent theta minus tangent 3 pi over 2 over 1 plus tangent theta tangent 3 pi over 2. Does that look okay? Houston, we have a problem. What is the tangent of 270 or 3 pi over 2? It's undefined. It's undefined. There's an asymptote at 270. So guess what? It was a nice try, but it ain't gonna work. Now, we can do this problem. We just can't do it that way. Do you have an idea about what we might have to do to make this work?
Sine over cosine or whatever.
Sine over cosine. What's the issue here, folks? The issue is tangent's undefined. There's two functions that are never undefined, sine and cosine. So we're gonna go back to the original problem and we're gonna write it as sine over cosine. So sine theta minus 270 or 3 pi over 2 over cosine theta minus 270. Now, is that the same as the tangent? Mm-hmm. And now, it's gonna be a lot, but I can do all that and not have to worry about anything being undefined. So here I go. What's my sine of a difference? Sine first, cosine second, minus cosine first, sine second. Cosine, cosine, plus sine second. So instead of using a tangent formula, I broke tangent apart into sine over cosine. And then I had to use my sine formula and my cosine formula. Would the tangent formula work sometimes? Would this be doable sometimes? Yeah, it's doable except at 90 and 270. If this was a pi, you'd be home free. But since it was an undefined tangent, can't do it. All right, here we go. 270 is down here. That's 0, -1, which means every cosine is a 0 and every sine is a -1. So, sine times 0 minus cosine times -1 over cosine times 0 plus sine times those are gone, would you agree? So what have I got on top? Cosine? And what do I have on the bottom? Negative sine. What am I supposed to be ending up with? Negative cotangent? Does that work out? It's perfect. Beautiful. Cosine over sine is cotangent. So we ran into a snag, so what did we do? Minus E2, right? Get it. All right, quickly, part 3, and then we'll go to lunch. Part 3 is the backwards of what we've been doing. So what you need to do is look at your formulas. Which one is sine, cosine, plus cosine, sine? Which formula is that? That's a sine formula. And is it a sine formula for a plus or a minus? A plus. So what are the two angles in the problem? What are your alpha and your beta? 22 and 13. So problem A is just a long expansion for sine 35. All right, what's B? Just read the words. Cosine, cosine, plus sine, sine. That's a cosine minus. And the two angles are pi over 3 and pi over 4. So common denominators, subtracting those. Did you get pi over 12? That's a formula for the cosine of pi over 12. You guys act like you've never eaten before. You're gonna get their lunch, hang on. All right, last one. For sine, sine, so sine, sine, minus cosine, cosine. Wait a minute, something's not right there. Do I have a formula that's sine, sine, minus cosine, cosine? But it's the opposite of the formula that I have. So isn't it the opposite of cosine, cosine, minus sine, sine? Now, I'm not using the right letters, but isn't that what's happening? Isn't it the opposite of this one? Okay, what's this one? That's a cosine of an angle plus an angle? So what are my angles in my problem? X and 2x. So that's cosine 3x. But because the formula was backwards, it's actually negative cosine 3x.
But it would not be a secant
No, negative cosine. All right, back in your seats at 50. Have a great lunch. Try not to step on any cereal.